so part two here is an introduction to using Onshape, which is different from SketchUp. Okay, so SketchUp is a very free-form, kind of more architectural CAD design software. Really, what you're supposed to be doing in SketchUp is making like low res images of buildings and stuff. You're not really supposed to be making like highly detailed small parts with dimensions and things like that. So Onshape comes from the same company that made SolidWorks, except Onshape is just all in the cloud, and it has a lot of the same features. Some of them are a little different, but basically, as you can see here, this little animation, way better for small parts, for making things very specific, making stuff fit together, making things turn with each other. Alright, so here's the Onshape panel, first screen that you get to, dashboard, when you log in. And we're going to go create a document. And we're going to name this HammerBot. And basically, similar to what the axes were in SketchUp, we have planes. So there's 3 different planes, and they all intersect in the middle here. So, big difference between SketchUp and Onshape is that everything is very, very well defined. So every single line that you draw has to have a dimension. Every single part that you make has to be fully defined, we say. So let's start out, let's try making the gearbox. So instead of having all your parts in one file, like in SketchUp, there's sort of one file is for every part. So instead of using that grouping and component technique, we're going to make just one. This is called Part Studio 1, but I'm going to rename this. So this is not. This is going to be. We're going to call this P60 gearbox. Okay. So first thing we have to do here is click on a plane that we want to start to sketch on, and if you hit the N key, it will rotate you normal to that plane. So you see if we can rotate around here, but if you hit N, it will make it so that you're looking directly perpendicularly at this plane. Okay, so now we're going to go to Sketch, and we are going to select our center point rectangle, and we're going to start in the center here, click, and we're not going to give it any numbers yet. And basically what we can do here is if we hit D, that's the dimension tool. So hitting D will allow us to select a line, and we click on it, we drag it off to the side, and we tell it exactly how big we want that line to be. So we need this to be 1.5 inches. Okay. Now you'll see that this has remained blue and this has become black. The reason for that is because the black means that it will not move in a certain dimension, and the blue means that it will move. So the black, because we have put that dimension of 1.5 inches, it is constrained in that direction. You could not, if you tried to drag these up and down, you see, it won't go any taller because it knows it has to stay to be 1.5 inches. And anytime that you see blue, it means that you kind of have to keep going. You have to keep giving it dimensions, otherwise it doesn't know exactly how large the shape is supposed to be. So now we can select the other side we have not told what size it's supposed to be, and do 1.5 as well. Good. So now that the entire sketch is black, that means that it's fully defined. Now, instead of doing like push-pull like we did in SketchUp, there's a tool, so we're going to hit just hit the check mark there. So this sketch is its own entity, and basically if we hit the check mark up here, that sketch goes back to not being able to be edited. But if we click on it, or we kind of double click into it, we can edit the sketch. Or we can go over here to the feature tree on the left, right click, hit edit, or we can even double click into it, and then that will allow us to change things in the sketch. So now that we have a sketch, very similar to what we have with SketchUp, is we have to push or pull it out into a three-dimensional shape. So here we have extrude. So extrude is the equivalent of push and pull. So you have to hit extrude. We want a new solid. That's kind of the default. You click on the face that you want to extrude. And you can see this is kind of the direction that's going in. You can rotate around the same way you did in SketchUp using the clicking of the mouse wheel. And we want this to be 0.3 inches. Good. So we hit OK. And now we've got a box that is 1.5 by 1.5 by 0.3. So instead of grouping things together like we did with SketchUp, we're just going to keep building. We're going to keep building on top of what we have here. So we're not going to select the plane that we started on before because that would have us building off of that plane. We're going to select this new face that now exists because of our extruded feature. So we're going to click on that. We're going to hit N, which is going to make us go normal to that. Okay. Yep. So click on and hit N. You can also right-click on a face and do View Normal too. It's a very useful thing to know how to do because it will put you directly on top of it. So now we have to go to Sketch again because we want a new sketch. And it's saying select a sketch plane. We want to select that new face that we just created as our new sketch plane. Now we can go over to Center Point Circle, which is up here. It's a sketch tool. Click on the middle point right here. Just bring it out. And now we can hit the D tool for dimension. Click on that. And now this does want the diameter as opposed to SketchUp, which wants the radius. So we click 1.4, hit enter. Good. And now we have a sketch of a circle on top of our box. Now what we have to do is go to extrude again, and see, it wants to know what sketch we're working with. So if we started to go to extrude directly from inside of the sketch, see here we're editing the sketch, and I hit extrude, it assumes you want the current sketch. If we're not in the current sketch and we hit extrude, we have to actually tell it which sketch we want it to extrude. So if we didn't click that sketch and we just clicked some other circle or some other face or feature rather, it'll think we want that face. So what we really want is the sketch that we just made. So we do sketch, we do extrude, we click on the sketch we just made, and see it selects that circle and it knows. And yes, we do want 1 inch here. Let me hit OK. Good. Now these are pretty much, it's all the same object. They're connected together. And we're going to move on to the next one. So I'll go View Normal 2. We'll do Sketch. We'll do this center point rectangle again. We'll click here in the middle. Now, if you want to reference points in a sketch somewhere else, right? So we can actually click on this point and click on this point, and you don't have to hit Shift or Control or anything. It will just continually select them. And we go over here, and these are ways that we can combine lines into each other. So we can make them coincident, meaning make 2 or more sketch entities share the same location. So we click on these 2 points, and we want them to be on the same point. We hit coincident, and then it will automatically go to that distance. Now, why is this important? Because we don't actually have to type 1.5. So what you really have to think about is sort of design intent. So maybe we wanted to change this to 1.75 instead of 1.5. If in the future we wanted to change both of these, we would have to go back and change both dimensions. I would have to physically open the sketch, change all the 1.5s to 1.75. But if I reference another sketch, meaning that I use these tools up here to make sketches defined by other sketches, then they will update automatically. So here, let's extrude this as 0.6 inches. Okay. Now, if I go back to sketch 1, back here, right, and I make this, 1.75. Now both of these have changed. So both of these are now 1.75 by 1.5. I'm going to hit Control Z to undo that. Now, but if I had not done that, if I had defined this sketch, I'm going to select, you can actually select the coincident constraint here and delete it. And if instead I had this be, we did the same thing, we did 1.5 by 1.5, And we said, okay. Now, if we go back in time and we go to our first sketch and we change something, 1.75, you will see that this one has become taller, this one has not. So if you want things to update in relation to each other, you have to constrain them relative to one another, which is this is the basis for what's called parametric modeling. Basically, that you have a certain base dimension, and then you can have sketches or features be dependent on those other dimensions, as opposed to having to tell in absolute terms, exactly what the distance is. So let's Control Z that again, and let's go back to our sketch over here. And instead of it being 1.5 by 1.5, I'll go View Normal 2. I'm going to click on this point, and do coincident. Nice. Excellent. So let's keep going here. We're going to make a shaft. We're going to go View Normal 2. We're going to sketch. We're going to get a circle. We're going to click in the middle here. We're going to dimension this as 0.5. We're going to extrude this out 1 inch. Very good. Okay. So let's say that I want to put some holes into this. So the gearboxes do have holes in the bottom that you can screw things into. So we would right click and we'd go View Normal 2. And now, because that whole face is selected, we can hit Sketch, and it's going to create a sketch on that face. Now we can go back to our gearbox up here, and we see that they've dimensioned off the middle, right? So this says that it's 3/8 of an inch, 0.375 from the middle point of the gearbox. So what we can do here is we can create our own middle point if we want. So if we hit the line tool, this draws a line. So we could draw a line from here to here. But we don't actually want to draw anything with this line. If we just wanted this line for reference, we can create what's called a construction line. So a construction line is a line that exists in the sketch but doesn't actually make a shape that you can create a solid with. So if we click on that line and then we click on construction up here, or it's also bound to the shortcut, the keyboard Q. If you hit Q, it'll give you a construction line. Hit construction over here. Now it becomes a dotted line. Now this dotted line means that it's just for reference. But now this is good because we've defined this line. I was clicking on the midpoint from here to here, which is the middle, and I went to the other midpoint. You can see that it sort of adds that midpoint constraint for us. That's what that little dot means. It means midpoint. You can see over here. It's the same thing. So now we have a line in the middle, exact middle of this face, which is useful because now we can draw stuff on it. So let's see where else we need to put this circle. So there's another line that goes 0.375 inches from the middle of the gearbox lengthwise. So something else we can do here is we can do another construction line. So we hit line, and now we hit here, construction, and we can just draw one line from the top to the bottom. And for some reason it didn't snap to the edge here, so you can just drag the point onto the edge and then it will make it coincident. See, that's the coincident constraint. So that means that they're attached. And let's do it again. I'm going to hit L. I'm just going to click anywhere, come down, and this time I forgot to say that it was going to be a construction line, so you can click that and then click construction. It'll turn to construction line. So now what you can do is you can hit the dimension tool, and you can click on this line, and you can click on, see how it's blue? It means that it can move side to side. It doesn't know how far it should be. So we click on this line, we click on this edge of the face, and basically we know that this needs to be 0.375. Yep. Well, it's really from the middle, isn't it? Okay. So let's go back here. So let's make another line. Let's whoops. Let's delete let's delete that. Okay. Let's make another line for construction, right down the middle. Here to here, 0.375. Nice. Here to here, 0.375. Cool. So now what we can do is we can get our circle tool, and we can go and hover over these two lines meet, the intersection. Very good. And now this will give us two circles. Nice. So you can see these circles are different diameters here. So what we can do is we can click one circle, we can click the other circle, and we can hit the equal constraint. Or we could also hit the E on our keyboard, so equal. So now they're the same size. And now if I change this one, the other one changes as well, whereas before it would not. So now we hit D to dimension this, and this circle, let's see, how much of a diameter here do we want? Okay, so this tells us that the mounting holes are 1032 size. So let's look up, we can say diameter of 1032 screw. Basically, a number 10 screw, the 10 is what refers to the diameter, and the 32 refers to how many threads there are per inch. So it looks like a 1032 screw has a 0.19 inch diameter, so let's put that in there. 0.19. Good. See, we only had to dimension one of these because the other one's automatically the same size because we told them that they're equal. So now, because these lines are dotted and these are solid, the only things that will ever make a shape are the solid lines. So now what we can do is, we don't want to add a shape here, right? We want to subtract. So instead of doing adding, solid add, we're going to do solid remove. So you have to hit the remove option in the extrude function here. And you can see it will kind of give you an outline of exactly how far it's going to go. You could drag this arrow, or you could also type in a number. So what does the gearbox say? It says 0.30 minimum depth. So this is at least 0.3 inches deep, it says. So let's make it 0.325. Nice. All right, cool. Okay, so let's do the same thing to the other side. We've got these two holes, but we're going to do it in a slightly different way because there's many ways to do the same thing in CAD. So we're going to click on that surface again. We're going to hit Sketch, and this time I'm just going to draw one line. So if you hover over a line and you get to about where the middle is, it will snap to the midpoint. And I make this construction line by pressing Q. I'm going to draw the line by going from midpoint to midpoint. Nice. Now I'm going to draw the circles here first. So there's one circle, there's a second circle. I'm going to make these equal. And now what we can do is we can even click on this circle and this circle over here and make them equal. So we didn't have to define them at all. So now the only place that is controlling the diameter of these circles is over here. Now you notice the circles are still blue, and that's because we can still move them along this line. They're not fully defined. Only things that are fully defined or fully constrained, meaning that you could not move them around, it will appear as black. So if we hit the dimension tool, we can actually click on the midpoint of this circle and then click on the midpoint of this line, and it will give us a dimension if we drag it across to that along that surface. And now we can hit 0.375. And we can do the same thing over here. Click from here, 0.375. So this is the same way of doing the exact same thing. It's just in a slightly different way. So depending on how many holes you have, depending on what's easier for you or how you exactly, like maybe these are not symmetrical. Maybe you wanted to make them move off to the side. Maybe this is 0.5 away. I don't know. When you're designing things, sometimes you have to decide if you're going to make things symmetrical or not. So we've got that. So we could have also included this in the other sketch because it's the same surface, but it's just a really good practice to create separate sketches, because if for some reason we changed the size of this surface and not the size of this surface, maybe the two wouldn't line up anymore, and then you have a problem. So it's typically good if you're going to change surfaces, just draw a new sketch. So let's go back up to extrude, and we got to do remove, and I think we did 0.325 or something. Good. And now it's got to be going the right direction. And if you want to flip directions, you got to hit this button. See, it knows that there's no material over here, so it's smart that way, and it knows that you kind of, if you're going to remove material, you got to go in this direction. But sometimes you have a choice. So, all right, nice. Okay, so we've got 4 holes on this side, but let's say we want 4 holes on the other side, which there are in this gearbox. I know it doesn't show it here, but there's yeah, see, four mounting holes on the top and 4 on the bottom. So it's a pretty symmetrical object. So what we could do is we could do this whole thing over again. We could draw more sketches, define them, and then do extruded cuts and get these holes. Or we could do something called a feature pattern. So basically we can mirror features that are symmetrical around a plane. So the reason why I created, and the reason why it's generally a very good idea to make things symmetrical about planes, is because then you can copy features and it saves you a lot of time. So if you go up here to mirror, click mirror, and it says part mirror, that's not what we want. We don't want to mirror a whole part. We want to mirror the features. So everything that we're doing here, extruded, extrude, 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 those are all features. So now it wants us to tell it the features to mirror. So basically, if we go over here and we mouse over the feature tree, you can see that it's highlighting on the right side the extrusions that they apply to. So that's one that we want, and that's one that we want. And now it wants us to tell it what plane, mirror plane. So we want to flip all of these features about this front plane. You can kind of see, if you were to imagine that this whole thing got flipped around about this plane, that's what we want. So we click that, and it'll show you a little preview. See how now it's copied from this side to that side? And now we go OK. And now if we click on this feature mirror, right, so this shows us all 4 because this is us copying all 4 of these over here. Whereas if we click over here, this is just 2 of them. And click over here, that's just 2. So really powerful, useful stuff. All of this would be so difficult to do in SketchUp. And here's the other thing that's really cool is that now if we go back, so when you hover over stuff in a feature tree, or you click on it, it'll highlight it to kind of tell you exactly what it is. So if we go back to over here, and remember, these sketches are what defines the extrusions. So extrude 5 goes with sketch 5. So if we double click on sketch 5, and let's say I wanted to change all of these holes, I changed my mind. The hole's diameter's got to be different. It's got to be 0.21. Here, let's make it bigger so we can see the difference. 0.25. I hit 0.25, I hit enter. So because we had already defined these as equal, those are going to change. Because we had defined these as equal to here, those are going to change. And because these are ultimately just a flipped feature on this side, these are going to change. So you see, you can change, if you design things correctly and intelligently, you can change one dimension and bam, 8 holes have all changed. So this is really the power of parametric modeling. And it's not that intuitive, but once you use it a lot, you're gonna want to use it. So let's hit Control Z here because I do want that original diameter. Okay, nice. So this is all one part. This is the gearbox, and there's another feature that we didn't make on the gearbox before because it wasn't really necessary for planning stuff out. But if we want to get nice and fancy here, we can do it. So let's go back to our dimensions. You see, there's actually these gearboxes don't have a sharp edge. They actually have a radius. So it's a curve. So what we can do here is we can simulate this curve. So I don't see anywhere where it actually tells us the radius of the curve or anything. So I don't know how steep the curve is, but let's just make something that looks like it's correct. So there's a feature called fillet and a feature called chamfer. Fillet is, so these are for like rounding off edges. So fillet is a curved edge. So if we click this edge over here, it will give us a circular fillet with a radius of 0.2 inches. See how this kind of shows us the preview? I'll just show you guys what that looks like. See how it has curve, that whole shape? And we can go over here and click the fillet and hit delete, and that will go away. Chamfer is the same thing, except it's just a line. So you see how we click on there, and we do 45-degree chamfer. So this gives like a 45 cutoff of an edge. And this is cool too because you don't have to do this one at a time. So if we can do this all with one feature. So if we click fillet, it says entities to fillet, right, edge, and I click on this edge, and I go down here, I click on this edge, and I go over here, I click on this edge. I did not mean to click that face. So see how it wants to fill the entire face? That's not what I wanted. So we have to go back up here and see how it says face of extrude 3. You gotta hit the X, delete that. Yep. I just want these edges over here. Nice, nice. And this edge, and this edge. Cool. And we hit OK. So now we got this nice curve. Now again, parametric modeling, you can change all of these at the same time. So instead of 0.2, if we want 0.05, we can type 0.05, hit enter. See how all of them update? So very useful stuff. I am going to keep it at 0.2. I think 0.2 looks about right. It's not that important, but it's just for the aesthetics of the part, and maybe for making other things mate. Okay. The other thing that we didn't put on here is a keyway. So let's keyways. Let me show you what a keyway is. Keyways are like grooves and shafts that you can place a square piece of metal in between, and they will allow stuff to attach to a hub. It's a very good way of transmitting torque to another object. So you have the key seat, the keyway, and the key. And these all, you can imagine, fit together sort of like a puzzle piece, and they lock in together. It shows it over here. A lot of cars have keyways on the drive crankshafts. They're very, very good at transmitting torque. Very hard to shear a keyway. You need a ridiculous amount of torque to do that. So they're very powerful connections, very simple, and pretty easy to make, pretty easy to maintain. And you can see right here on this gearbox, they are keyed shafts. So it shows 0.125 keyway shaft to shaft end. So let's put in our keyway. So what I'm doing is I'm going to the very end of the shaft. I'm going view normal 2. I'm sketching on the top here. So now this is our sketch. I'm going to draw another center point rectangle, and I'm actually going to overshoot this because I want to extrude and remove material. So I'm going to go past it. And then I'm going to draw another rectangle inside of it, and I'm going to attach this vertex to this vertex. And because it was 0.125, that is the width of the keyway, 0.125. And this doesn't have to line up. You could select this line and select this circle and make them tangent. Tangent means that there's one point that they intersect. You could do that, or if you're lazy, you really don't have to. You could just make this something that's larger than the diameter and make this 0.75, because it doesn't really matter. As when you're removing material, it doesn't intersect with anything. But just for the sake of being clean, we'll select this, and we'll hit tangent. That's a tangent constraint. Good. So 0.125, I think that also means that the shaft keyway is only 1/2 of that, probably 1/16. of an inch deep, because I think the overall key stock is a square, so it's like 0.125 by 0.125, so half of that is a 16th. So now what we can do is we go to extrude, but remember, we're going to remove material here, remove. But we don't want this whole square to remove, right? We just want this tiny rectangle. So what we have to do is we have to deselect everything else. So go over here, deselect that, deselect that, deselect that, deselect that, and that should be good. So now you can see only this part of the sketch is being used in our extrude. Could you turn all these other lines into construction lines so that they don't extrude? You could, but it's a lot easier and faster just to do it this way, just to say, hey, I only want this rectangle to be extruded. So it doesn't really go all the way down. It kind of goes maybe like that far. I don't know. They didn't really specify, did they? Okay, it goes almost all the way. So maybe we do 0.9. Yeah, that's good enough. And we hit OK. Now over here it kind of looks filleted, doesn't it? Yeah, it kind of looks like it's filleted. It's got a curve. So what we can do here is we can put in our own fillet. Go fillet and click here and click here. And when it's way too large, it will tell you. It will say, hey, I can't build this thing. It will give you an error. The red text means that there's some sort of build error. So if we make this 0.125, let's see what that kind of a fillet looks like. Okay, maybe not. 0.0625. There we go. So that's like the largest that you can have between those two walls. And the reason why there's a lot of curves in geometry and stuff like that in general when you're building stuff is because if you think about the way that certain things are machined or made, a lot of the times they're using a circular end mill or a circular drill bit, right? So having the sharp corners is not always possible. So that's why learning to use fillets is important.